Hello again, welcome to this lesson. We are going through our mid-year exam, doing revision on the questions there, and I'm simply actually just doing the whole question paper for you. So let's go through that. We're on question 4. Question 4 was our number patterns question, and not so happy about this question in general. Went well, but I think there's a lot of understanding needed with just some of the words being used. My first very big problem is I don't know of anyone that could do this proof, and I told you this proof was going to be in the exam. I think one person could do it, and yeah, I had my doubts about that person. So let's see, look at this. So prove the sum of the first n terms of the geometric sequence is given by. So here's the proof. It pains me deep to have to do this proof in a revision video. But yeah, people just couldn't do it. They didn't study it. The proof is given and I told you it's going to be in the exam. So here is the sum of the first n terms of a geometric sequence. So there was your first mark. Next is you have to multiply everything with an r. So yeah, there's a few steps you have to follow. Multiply everything with an r. So a times r is ar, plus ar times ar is ar squared, plus ar squared times ar is ar cubed, plus blah 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 blah. And then the second to last term here was ar n minus 1, n minus 2. So if I multiply this term ar n minus 2 with an r, I add 1 here, so n minus 2 plus 1 becomes ar n minus 1. And then this last term becomes, when I multiply this with an r, is ar n. I just add a 1 to the r's because I multiply with another r. Okay, and so there goes another mark. 5 marks, by the way. Just 5 marks. That is 5%. Ridiculous. So again, if I look at this, my next step is simply subtracting the 2. So I've got Sn minus Rsn, and yeah, there's a method you have to study. So subtracting the 2, there's nothing to subtract here. So you notice how I indented this expression. That's just so that I have my like terms underneath. It's nice and pretty, easy to do. A minus 0 is a minus r is 0. Ar squared minus r squared is 0. Whatever, well, then this one will be ar cubed minus ar cubed 0. So this is going to go on until I get to this last term of my first expression, which is ar n minus 1, and he has a friend here, so that's going to be 0. And then I've got plus 0. There's nothing else here, but there's still another term here. So this one has an extra term in the beginning, that one's an extra term at the end. So now when I subtract, I've got this left. 0 minus Rn is Arn. And that was your next point, subtracting the two expressions. And then when I do that on the left hand side, I'm going to, because remember I want an expression for Sn. So to get that here, I just take out Sn as a common factor. Okay, Sn, sum of n terms. And on the right hand side, I take a out as a common factor. These two, there's an a taken out as a common factor. And I mean, this does give you leading there. A is out as a common factor. So I'm left here with a 1, and on that side with a minus Rn, exponent n. And I need Sn by itself, so I just need to divide the other side. So 1 minus Rn over 1 minus r. That's it. So sorry, taking out the common factors, on the left hand side was 1 mark, on the right hand side was another, and then simplifying that by dividing on the other side. Oh, sorry, no. Was it 2 marks there? Just 1 for taking out the common factors, 1 for the final step, and that is the easiest of the 2 proofs. There's 2 proofs. You must know this one and the other one. really not difficult. Please, guys, get with the party. Okay, consider the series. Here we have a series. Consider that series. What type of series is this, and what is the general term for this series? Well, how do we find out? Well, it either has a common difference, or it has a common ratio, or it has a common second difference. So let's see. Let's start with common difference, since if there's not a common difference, then I can do the second difference at the same time. So negative 4 minus 7 is plus, sorry, negative 3 minus that's. So what's the difference here? Well, 4 was added. From negative 3 to positive 1, 4 is added. From 1 to 5, 4 is added. So I keep adding 4, so there's a constant difference. If there's a constant difference, this is an arithmetic. So this is an arithmetic sequence, and what is the general term for this type of series? Not for this series, for this type of series, and the general term is t. Let's not do red. Tn is equal to a plus n minus 1d. Yo. That was just it's called a knowledge question, just a question testing your knowledge. So two free marks actually. It's what it is. It's called a free mark question. I just called it that. Write this series, that series, in sigma or sum notation. Okay, so you couldn't not have known what you should do there. You must write this series in sigma sum notation. Now it's standard routine procedure, although it is a level 3, which makes it complex. So this is what it is. I goes from 1 to n. There it is. That's so all we now need to do is find the general term for this specific expression. Instead of n, just use I, and then I need to just find out how many terms there are. So this is the number of terms. Then I need ti, which in the end comes down to this. I is equal to 1 up to n, which is the number of terms. Ti is then just a, which is the first term, the alpha term, plus n minus 1d. D always represents the difference, and we're not using n now. Look, I said it's ti, so I minus 1, and then d is the difference, the constant difference. We already saw the constant difference was 4, isn't it? Because each time I was adding 4. The first term is given as negative 7. Okay, so let's just get back there. That's negative 7 plus 4. So this is not difficult at all. I is equal to 1, negative 7 plus I minus 1. 4. You didn't even have to simplify. Oh, wait a minute. N. How many terms are there? Well, before we get there, let me just show you. This counts how many marks? 4 marks. Let me just show you all of the terms. Well, for 1 is you get a mark for your first term. You get a mark for your constant difference. You get a mark for just putting it all correct into this expression. And so you could have gotten 3 marks, 75% of this question, just by knowing this, and then doing a very simple construction of the rest. The only difficult part, and it's not really difficult, but the only challenging part was finding out how many terms there are. And we could do so by just saying, well, we have to go up to 65. So at what point am I at 65 if I use this? Negative 7 plus I minus 1, 4. So what I value, what will be the highest value for I to get at 65? 65 minus 7 added to the other side gives me 72, is equal to I minus 1 times 4. I'm doing red again. Okay. Divide both sides. That gives me, is it 18? I think so. So I minus 1 gives me 18. I just divided the 4 on the other side. I minus 1 gives me 18, so I is equal to 19. 19 minus 1 is 18. So that's my final answer. I get not, well, I'm going to rewrite it. Okay, there we go. From 1 to 19, and there we go for my full marks. So again, not difficult. Here, this question, okay, I don't think people really got the intention. No one answered it the way I was hoping, but nevertheless. Consider the following pyramid: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 16. The first question was a freebie question again. So 16, 17, 17, 18, 19, 20, 1, 2, 3, 4, and 5, up to 25. So the next row, row 5, has it goes from 17 to 25. That was all you had to write down for that point. If n is the row number, so this is row 1, 2, 3, 4. If n is the row number, prove that the general term for the median number of each row is given that. Now here's the word prove. When you see the word prove, you're not allowed to use what was given. You have to arrive at that point. Okay. The only time you can use what was given is if you prove a contradiction. And then you prove, but it doesn't work, and so you've proven that it's not that. But if you have to prove something, you're not allowed. You'll see the next one, and the next one says show, which was actually, I should have said this last one as well, prove, because of the amount of points I gave. This should have been prove, and I regret not making it prove, because I had to mark most of you correct for this question, and you didn't do what was expected. But anyway, prove. I have to prove that the general term for the median is given by that. So how do I do that? Well, I just write down the median. The median is the first, the middle term. So there's the middle term, 1, 3, 7, 13. So 1, 3, 7, 13, 1, 3, 7, 13. And then I go and find out what type of sequence it is. 3 minus 1 is 2, 7 minus 3 is 4, 13 minus 7 is 6. That's pattern itself with a second difference of 2. And now this is a quadratic equation, which we knew from the beginning. Actually, we could see this was a very simple question. We could see that this is a general, this is a quadratic. And we just have to show that the general term for this quadratic sequence is Tn is equal to n squared minus n plus 6. Is it? Plus 1. Okay, plus 1. Good. So let's have a look at that. So if I subtract, well, I like to go back one step. So this one will be 2. 6, 4, 2, 0. Okay, following this number pattern backwards. And so this is 3 minus 2 is 1, 1 minus 0 is 1. So the reason why I do that is because 2a is equal to that, c is equal to that, and a plus b is equal to that. So if 2 let me just see something. Something's odd. No, I'm the odd one. Yeah, no, everything is fine. So if 2a is equal to 2, then a is equal to 1. If a plus b is equal to 1, and a is equal to 1, then b, sorry, not equal to 1, is equal to 0, then b must equal to negative 1. So that 1 minus 1 is 0, and then c is equal to 1. How simple is that? So Tn is equal to an squared plus bn plus c, and so this is a is 1, so it's n squared, b is negative, it's 1 plus c. That's exactly what I have to arrive at. Please remember, prove. Prove means I cannot use what was given. Okay, cannot use what was given. Very important, please. Now, show is a different story. If you have to show something is true, then you just show while it works. But prove, you have to prove that this is it. You can't just show that it works. Now, if you want to show that something works without actually proving it, for a quadratic number pattern, you have to show it for at least 3 terms. Because here, let's say I only had, at least 4 terms. Let's say I only had 3 terms. I only had these 3 terms. Then my constant difference is, my first difference is 2, 4. My second difference is 2. I don't know if it's constant. If I didn't have a 4th term, I wouldn't have known that it is a quadratic number pattern. I would have just, I wouldn't have been able to see any pattern here. 1, 3, 7. Yeah, it could be. I mean, could be, but it could be something else. Like if 13, for example, yeah, I don't know, this difference could be 8, so I could maybe have a constant second ratio. I don't know, but point just being is, if I don't have the 13, I don't know that this is a quadratic number pattern. So when it comes to the next question, if n is the row number, prove, okay, we're done. Show that the general term for the first number of each row can be written as that. So do you see? Show that the general number for the first number of each row can be written as, again, they're asking me to find the general term for the first number in each term. Now notice what this is. This previous, it's the median minus the median is the middle term minus the 1 minus the row number. So for example, 3, this is the second row number, okay? So the median is 3 minus the row number is 2, 1 minus the row number is 1. So 3 minus 1 is 2. Here's the median, 7 minus 1 minus the row number is the row number is 3. So 7 minus the row number minus 1. So 3 minus 1 is 2. So 7 minus 2 is 5. Here's again the median. Okay, minus the row number minus 1. 1, 2, 3, 4. 4 minus 3 is 4 minus 1 is 3. So 13 minus 3 is 10. You see? So it's so that is one way you could have shown it. Another way you could have shown it is you could have just substitute in the first term of every of at least 4 and shown that this works for at least 4 terms. Why? Because it's a quadratic number pattern. You need at least 4 numbers to have proven anything. Well, not to have shown that it is indeed true. Okay? And another way you could have done it is you could have just found the general term for this. So you could have done what we did here, found the general term. So it's 1, 2, 5, 10, and that is 1, 3, 5, 2, 2, go 1 back, so it's 3, 2, this is negative 1, 1 minus negative 1, it would be 2, so our first term, I went back, so this is 2a is equal to 2, a plus b is equal to negative 1, so if a is equal to 1, b must be equal to negative 2, because 1 minus 2 gives me minus 1, and then c is equal to 2, so that we have n squared minus 2n minus, or plus 2 minus 1, yeah, plus 2, okay, and now, so this is my general term for the first terms. And now I must just show that this is equal to that. And that's very easy, really. I can just simplify that. So on the left-hand side, I have that. On the right-hand side, I had n squared minus n plus 1 minus n minus 1. So I just get this side. Well, I don't know if it's equal yet to that side, so I shouldn't have that. But n squared minus n is minus 2n plus 1 minus 1 is plus 1, so it's plus 2. And so, yes, I used what was given, but I only used it to simplify it so that I can show, but well, what I have here and what I have here, they're actually the same thing if I simplify it. So I can use it, but not to prove anything. I just use it to show. So this was actually proving it. This was proving that it is true. If I just had to show it, I just had to show, well, this works for all of them, that the median in each row plus the previous row number gives me the first term. I show that for all 4, or I show that if I substitute all 4 in here, or I can prove it as well. To prove, I am showing something, but just because I'm showing something doesn't mean I'm proving it, if that makes sense. Finally, let's get to the last one. Show that the median of each row is the mean of the first and the last terms in each row. The median of each row is the... Now, I wanted it to be proof. I wanted you to prove it. And so I wanted to show that if you find the mean, in other words, the average between the first term and the last term, you will get the median. And I wrote show. So let me show you the proof for this. If I wanted to prove that the mean, how do I find the mean? I take the first term and I add the last term. Now, what is the first term? The first term is given by that expression. The last term is this one. Now, what I wanted you to notice is that the last term is just the term number squared. This is 1 squared, 2 squared, 3 squared, 4 squared. So if I got the mean of the first term, which is n squared minus n plus 1 minus n minus 1, there's the first term, plus the last term, which is always n squared, divided by 2, what do I get? So I get 2n squared. 2n squared divided by 2 is just n squared. Minus n is 2. So negative 2n, so that's just negative n. And then 1 minus 1 is plus 1, so that would have just been plus 2 divided by 2 is plus 1. And this is the median that I worked out in question 4.3.2. So that's how I wanted you to prove it. Again, what most people did, and if I didn't, let me know, I had to give you the marks. If you just showed it for 4 numbers, I would give you the full marks. If you didn't show it for 4 numbers, I gave you 1 mark if you just knew what the mean was. But I should have given it only full marks if you did all 4. So what should you have done? You should have shown that, well, 1 is the median and mean. Okay. 2 plus 4 is 6 divided by 2 is 3, which is equal to the mean. And then the next one is 5 plus, where did that one go to? 5 plus 9 over 2 is equal to 7, which is equal to the mean. Let's call this mean 2. This is mean 3. And then the last one is 10 plus 16 over 2 is equal to 13, which is equal to mean 4. Sorry, not mean, median. Sorry about that. Median 4. Okay, and in the first one, since we have to do it for, this is median 1, and it is mean it's 1. It's the only number I can't. It's 1 plus 1. 1 plus 1. It's the first and the last term is 1 plus 1 divided by 2 is 1. So that's median 1 as well, the only term. So yeah, basically I didn't really care about that one, but you had to show it for the other 3 to get the full marks. If you didn't, I would have given you 1 mark for your method. If you did something similar to this, but you only did it for 2 or 3 marks, okay, or 3 points. Cool. So that was question 2 again. That took me 25 minutes to do. I didn't intend to spend so much, but I did a little bit more. So 21 times 1.2 is equal to 25.2. So okay, that's how long I took on this. So with explanation and etc. Multiple approaches to answers. Anyways, so thank you guys. Thank you for watching. I don't know what else to say other than your prelim exam will be more difficult. So good luck.